Welcome to yet another class. I'm Dr. B, your chemistry teacher online. As a matter of fact, your science teacher online. And today, you and I will be discussing extraction of calcium metal. Remember that in our previous class, we have discussed extraction of sodium metal. And today, we are going to look at the extraction of sodium metal. We're going to take the extraction of these very important and crucial metals one after the other. Do not forget that in this class, you are supposed to share this class as soon as it pop up in your screen. Share it to your colleagues, to your friends, your group platforms, right? And then encourage them to subscribe. Subscription is free. So let them subscribe so they can also be a part of what we are doing here. Now you also can find me on Facebook, all right, Dr. B Science Classes. There you can also share and ask them to follow as well. You can like and also leave comments. Even their questions will attend to them. Thank you very much. Dr. B Science Classes is the Facebook and the YouTube handle. All right, so today we're going to look at extraction of calcium. But it's important for you to know that calcium is also a very reactive metal like sodium. Just like we have said that sodium is quite reactive, so you should not try mixing it with water or mixing it with dilute acids at home or anywhere. The same thing goes with calcium. Calcium is also quite a very reactive metal, and because of its reactivity, it's difficult for you to find calcium so free, okay, as an element. So we cannot find calcium as a free metal or as a free element in nature because it is highly reactive. But calcium is also a member or one of the elements in the periodic table. Alright, just like sodium is group 1 in the periodic table, so calcium falls around group 2 in the periodic table. Now, calcium is a reactive metal, like we say, and calcium is always seen to be in the form of calcium carbonate. All right, so usually you find calcium as calcium carbonate. Okay, now as calcium carbonate, you see it in marbles, okay, or you can even find it basically in limestone. Okay, so you can be able to get calcium from limestone, okay, from limestone, and that is why limestone is commonly being described as calcium carbonate, a major source of calcium carbonate. You can find it also as marble, okay, or even chalk, as the case may be. So these are the various forms to which you can find calcium existing. You can also find calcium existing as calcium sulfate or even as a solution in salt water. So you can find calcium in all these forms, but it should interest you to know that calcium, which is being the oxide of calcium which is being used actually in the extraction of calcium, is not really from a direct calcium carbonate or limestone. Usually it is from the solvay process. The solvay process is a process that is used in the production of sodium carbonate. All right, so it is from the solvay process you can easily have calcium chloride, because calcium chloride is the major ore of calcium that is used to extract calcium metal in its pure form. Now, when you go to the solvay process and you react sodium carbonate with with sodium chloride with calcium carbonate, you should be able to get calcium chloride. So if you react sodium chloride with calcium carbonate, you will see that the sodium will react with the carbonate. You now have sodium carbonate, and then the chlorine will now react with the calcium. You now have calcium chloride. Now, this calcium chloride, which is a byproduct of the solvay process, is what is being used in the extraction of calcium metal. Alright, so we do not use calcium carbonate as limestone directly to extract calcium as a metal. We rather pass that calcium carbonate with sodium chloride in the solvay process to obtain sodium carbonate. and then the byproducts of that solvate process give rise to calcium chloride that is now used in the extraction of calcium metal. Okay, I want us to know that calcium is quite reactive. Calcium reacts with air to form a tarnished, a tarnished process, okay, of the metal. All right, at the end of the day, giving you calcium oxide. Calcium also, like I said, is quite reactive, so it reacts also with water. The difference between calcium reaction with water and sodium is that sodium reacts very vigorously with cold water, giving you hydrogen and sodium hydroxide. But calcium does not react very much vigorously with cold water, but with warm water. So when the water is warm, there is a rapid reaction for calcium and water, forming calcium hydroxide. But if the water is cold, unlike sodium, calcium reaction is always very slow. Alright, very slow. Now, that is the reaction of calcium with water. Now, calcium can also react with dilute acids. Like we had said before, that sodium reacts with dilute acid explosively. And you shouldn't try that kind of a reaction at home or anywhere. And the same thing with calcium. Calcium, in its own way, reacts with dilute acid vigorously. And this reaction will always be such that you do not need to also try it at home. It's quite very dangerous. So calcium, like sodium, are all very reactive metals. So you can see that calcium reacts with hot warm water quite rapidly and slowly with cold water, and it reacts also with air to do what? To form a tarnished structure and then give rise to calcium oxide, and also react with dilute acids to give you a very vigorous kind of reaction at the end of the day. Now, that is much we can look in terms of the reactivity of calcium. Now, do you know that calcium as a metal, just like sodium as a metal, is quite reactive, number one. Two, calcium as a metal is also what? It has a sort of silvery gray coloration. Another sodium, we had said earlier that sodium is silvery in nature, but calcium is silvery gray in nature. Calcium also has a physical property. Its relative density is about what? 1.55. The density of calcium is quite higher, quite higher than the density of sodium. If you look retrospectively to what we had done earlier concerning sodium. So calcium has a relative density of about 1.55. It is also quite conductive, both thermally and electrically. Okay, so it is conductive, it's thermally conductive, and electrically what? Conductive, as the case may be. It is also malleable and ductile. Remember, we had said already that sodium as a metal was soft, so it is malleable. The same thing with calcium metal. Calcium metal is soft and also malleable and ductile. Now, those are some of the physical properties of calcium. I have been able to take you through how calcium ore is obtained before it is being used in its extraction. I've been able to take you through a few chemical properties of calcium, and I've taken us through also a few physical properties of calcium. Now, do you know that calcium extraction is by the use of a graphite carbon container? Now, this graphite carbon container is built in this way so it can be able to house the presence of the fused calcium chloride and calcium fluoride. Okay. So you have calcium chloride and calcium fluoride inside the graphite carbon container which is used. Now, why it is called a graphite carbon container is because the container is built with graphite, which serve as the anode. Okay, so this graphite container is actually built with a wall that is lined with graphite. And so the container itself serves as what? The anode. And remember that the anode is always positively charged. And then it also have an ion cathode, which is a water-cooled ion cathode. Okay, and that of course is where the calcium metal is deposited. once the ion cathode, which has a continuous run of water, cool water through it, is immersed in a solution of fused calcium chloride, there is a preferential discharge of ions where calcium metal that is positively charged will migrate to the ion cathode, which is negatively charged, and the chloride gas, or chloride ion, okay, that are negatively charged will now migrate to what? To the graphite anode, which is positively charged and collected as chlorine gas. Now, it's important for us to know that in this extraction, it is not only calcium chloride that is being used. Usually, calcium fluoride is also introduced, but why? Sometimes about 1/6, okay, 1/6 of the mass of calcium chloride as calcium fluoride is used in this particular experiment. The reason is to lower what? The temperature. Remember that this extraction, this cell process, usually the mixture of this entire system usually run at a higher temperature. That's about 700 or something degrees Celsius, and usually the presence of calcium fluoride is to lower the melting point of the entire mixture. So the calcium fluoride introduction is to do what? Is to lower the melting point. Now, if it lowers the melting point, it becomes quite easier for you to have the calcium metal being accumulated at the ion cathode. Then it can easily be collected. So calcium fluoride is always used to do what? To lower melting points, bring it down to about 600 degrees Celsius, as the case may be. So the calcium fluoride do not really have any impact. It plays on the deposition, okay, at this point. So it will help to lower the melting point and allow calcium ion to deposit. So now, what happens around the cathode actually? What happens around the cathode actually is this: that there is always a gain, okay, a gain in electrons. If you are defining oxidation and reduction by electron transfer, you will know that when there is a gain in electron, there is always a reduction process. So which means that at the cathode, usually there is a gain in electron, and if there is a gain in electron, then there is a reduction reaction taking place. So the reaction that gives rise to calcium ion in its extraction is a reduction reaction, and this is how it follows. So we'll have calcium 2 plus 2 electrons giving us calcium itself. So at this point, this is the addition or the gain of electron here. Now, because of the gain of electron, we term this entire reaction as a reduction reaction. So the reaction that takes place at the ion cathode water-cooled area that allows for deposition of calcium metal is a reduction reaction where there is a gain in electrons, 2 electrons. And what happened around this graphite, okay, the graphite wall or the anode, is an oxidation reaction where there is a loss of electrons. So in that way, we will say chloride ion will lose electron, and you can have chlorine gas that is formed at the end of the day, plus 2 electrons. So you can see that at the cathode, there is a reduction reaction with a gain in electron to form a calcium metal, and at the graphite anode, there is an oxidation reaction where there is actually a loss of 2 electrons to actually form a chlorine gas. So calcium metal is formed at the cathode through reduction process, and the chloride gas is formed at the anode through oxidation process, and the entire process is an electrolytic process. So the process that gives rise to the extraction of calcium metal is an electrolytic process. process of electrolysis. And usually this process gives rise to about 99.8% purity of calcium metal. But should you sometimes feel like you should also carry out another type of purification, you can possibly allow yourself to make use of vacuum distillation. So usually people in industries who that are responsible for the extraction of calcium metal, if they feel that the purity of calcium from this electrolytic process isn't enough for them, they will pass this particular product, the calcium metal, through what? Through a vacuum distillation process, and then they can obtain a desirable pure calcium metal. But why are we interested in the calcium metal? Do not forget that it is a deoxidant in steel coating and in copper alloy. Okay, so where the calcium metal is basically used in as a deoxidant. Okay, as a deoxidant in basically in steel. Okay, in steel production, and also as alloy of copper and all those stuff. And then apart from that, apart from steel coating, you can also see it being used in can also see copper being used to produce compounds like calcium hydride or even calcium fluoride. Okay, so it's not only it's not only in as a deoxidant. Okay, in steel steel coating, it is also or in carbon alloy formation, but it is also being employed in the production of calcium fluorides and calcium hydride or even calcium hydroxide. Okay, and a lot of other compounds produced from there. It is also being used in the extraction of uranium. Okay, remember that we had mentioned a thing of this nature with sodium. So even in the extraction of uranium, calcium is also being required. So it is also used generally and health-wise in strengthening of bones. Remember that calcium is one of those compounds that is encouraged to be taken for strong bones. All this and many other relevance of calcium make it important that the chemical industry will have to do what? Have to produce calcium, and other industries, especially metallurgical industry, have to extract what? Calcium. I'm sure that we have gone a long way discussing about what calcium is, the properties, its or how it can be obtained, in what form it can be obtained, its extraction, its uses. Now you can see how important this class is. Do well to follow me. Do well to also share this class to your friends. Dr. B Science classes.